I am Anil Kumar. Welcome to our YouTube channel, a learning platform absolutely free since last 15 years. Let me thank all the viewers and subscribers for sharing brilliant questions. And now these questions help you do better in your exam. Here is a problem based on sequences and series, which is under the series of IBHL math test preparation. The question here is: the sum Sn of the first n terms of a sequence is given by 3n squared plus 5n over 2. Find the nth term of the sequence, and B is prove that the sequence is arithmetic. Now, let's try to understand how do we solve this problem. What we are given really is sum of n terms, which is 3n squared plus 5n over 2. And we have to find the nth term. So Tn, let it be the nth term. This is what we need to find. So from this sum, how do you find the nth term? Well, the strategy is that the nth term will be sum of n terms minus sum of n minus 1 term. So you're left with the nth term. That's great. So it be sum of n terms minus sum of n minus terms. Simple as that. So once you get that strategy, it's very easy, right? So let's go ahead and find the nth term, Tn, which is basically sum of n terms minus sum of n minus 1 terms. So n term sum is given to you, which is 3n squared plus 5n over 2. So how do you get sum of n minus 1? Replace n with n minus 1. Perfect. So you get 3 times n minus 1 whole square plus 5 times n minus 1 over 2. So just replace n with n minus 1, you get your result, right? So now let's simplify this. To find the nth term, we can take half common. You're left with 3n squared plus 5n minus. So here we have, let me put another set of brackets here. Let's select this. So we have 3 times n squared minus 2n plus 1. And then we have plus 5n minus 5, right? Great. So we could write this as half of. Now let's 3n square and 3n square, you can see that cancels, right? And then you have 5n and 5n also cancel. So let's open rest of it with a negative sign outside, right? So take care of this negative sign. So when you open, negative and negative becomes positive 6n. And this negative with 5, so here we have minus becomes positive. This is 3n. So we get plus 2n, plus 2. So that gives you 3n plus 1. Correct? The number minus 5, and here we get plus 3. So minus 2, but minus outside makes it plus 2. So we get the nth term as 3n plus 1. So that's our answer for part 1, which is 3n plus 1. That is your nth term. Now, let's answer part B, which is prove that the sequence is arithmetic. Now, how do you show that the sequence is arithmetic? Well, you can show that the sequence is arithmetic if the difference between n and n minus 1 is constant. So that's what we are going to find. So let's figure this out. So we also figured out that the nth term was equal to 3n plus 1. And so the difference between the two will be what? So it'd be 3n plus 1 minus. So let me use a square bracket. Rather, the curly bracket is always better to put outside. 3 times n minus 1 plus 1, correct? So which is 3n plus 1 minus 3n minus 3 plus 1, correct? Which is 3n plus 1 minus of 3n minus 2. And if you open this bracket, 3n cancel, you get 1, and minus and minus 2 becomes plus 2. Sorry, plus 2. And that will be 3, right? So you see that the difference is constant. Since this difference is constant, we should write this as an arithmetic sequence, right? Makes sense. That is how we are going to solve this problem step by step. I hope the concept is clear. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best. Follow my book and bring alive the real experiences. Thank you and all the best.